The function of the delay object is to output the sound sometime after it was presented at the input. This object defines time in number of samples. The first argument specifies the maximum possible time for which some space is reserved. The second, the initial delay time. Making the amplitude half as loud as the original creates an idea of echo. Duplicating this step represents a second bounce. Instead of recreating the same object, we could instead try to feed the sound back into the delay. But Max is unhappy, the Max window shows. Audio objects feeding back into themselves create infinite recursion and is not allowed. However, Max provides a way around this using a tap delay with separate objects for in and out. Then it is possible to create feedback. Here, delay time is specified in milliseconds. This solution comes with a price, however, as it sets a limit to the smallest delay time that can be created, which is determined by the signal vector size, it says here. The delay time can be adjusted with a number box to the tap-out object. The maximum delay time is limited by what is reserved by the tap-in object. 1 second of delay time requires the adjustment of that object. The feedback level can be adjusted too. Be aware for the possibility of building up feedback that creates very loud sounds. As a safety measure, the clip object can be used, which limits the output between -1 and 1. A tap delay with feedback can also be used to capture sounds. This requires a switch which selects either the input or the feedback. The selector object is useful for this. The argument 2 creates 2 switchable inlets. A clear message for the tap-in provides a means to erase the sound from the delay. Whenever the selector switches to the second inlet, the sound will continue to loop inside the delay. This switching, however, creates audible clicks. We could look at a better alternative. That is represented by the matrix object, which can connect inlets to outlets. The amount of them is provided as arguments. 2 inlets, 1 outlet. The ramp attribute can be set with a millisecond value, creating a fade time for transitions. This object needs a specific control, which is found in the buttons section. The default layout is for 8 inlets and 4 outlets, but that can be changed in the inspector. It would be good to limit the amount of connections to a single one, and auto-sizing is fine too. Developing this principle a little further could include modulation that is also looped as an audio signal. The first step is to extend the delay to 3 seconds. The input to the second delay is a rand object which moves from one random value to another, controlled by a frequency. The output of this loop is turned into a gate signal and smoothened before multiplying it to the sound from the left loop. Before testing, the delay time at the right will be made a little shorter in order to create a shift in relation to the left loop. The inlet of the tap-out object also accepts audio input. This is useful for creating smooth, continuously changing delay times. A cycle object can provide the control signal. This signal needs to be mapped to a different range using the scale object.
The
pitch change is the result of moving with or against the flow of signal. This process can be driven by a phasor as well. The result is a steady pitch change. The clicks happen when the phasor resets. The up-down object will create a short fade at that moment. By adjusting the mapping, various pitch relationships can be tested. Whenever the start point is higher than the end point, the pitch goes up. Lowering the end point decreases the pitch until a point where it starts to go up again. At this point, the chunks play backwards. Also in pure data, tap delays are created with two objects. Here the connection between in and out is not made with a patch cord, but with a reference name instead. If the objective is to change the pitch of the material with a signal input, the tap read 4 with 4-point interpolation is a better option.